In this video, we're learning about weather patterns. So we'll cover how temperature and pressure affect water movement in the atmosphere, how landforms influence weather patterns, and then finally, how ocean temperatures influence weather patterns. Let's start by going over how temperature and pressure affect water movement in the atmosphere. Water vapor doesn't just move straight up and down in the atmosphere. It also travels horizontally across vast distances in complex patterns. These patterns themselves are also constantly changing, though, due to differences in two main factors: temperature and air pressure, and these vary across different locations. In terms of temperature, this affects the amount of water vapor that the air can hold, where warmer air holds much more moisture than cooler air, making the cooler air more dry. Differences in air pressure are important because they drive the formation of winds, and winds are the main force that move water vapor around in the atmosphere. When temperatures are higher, the air becomes less dense and rises, and this then creates low-pressure areas. Cool air is denser and sinks, so has the effect of creating high-pressure areas. So, overall, wind flows from high-pressure areas to low-pressure areas, and this movement carries water vapor with it. At this point, let's take a moment to look at what happens when warmer air meets cooler air. In this scenario, the warm air is forced to rise even more quickly, before it then quickly cools down higher in the atmosphere. And because warmer air typically contains a lot of water vapor, when it cools down, the water vapor it's carrying condenses, and this creates heavy rainfall or thunderstorms. The direction of the wind determines where the moisture comes from, with winds blowing from oceans bringing humid conditions and possible rain, whilst winds from dry inland areas bring clearer, drier weather. However, it's not quite as simple as winds flowing in straight lines from high to low pressure areas. Because the Earth is spinning, moving air gets deflected and curves, and this is why weather systems are often spiral, rather than moving in straight lines. All this together creates the large-scale wind patterns that move weather systems across continents. Low-pressure systems are large areas where air pressure is lower than the surrounding areas, and they typically bring clouds and precipitation, because the rising air cools and its moisture condenses. High-pressure systems, then, are large areas where air pressure is higher than the surrounding areas, and they usually bring clear, dry weather because the sinking air warms up and can hold more moisture without condensing. Next, let's explore how landforms influence weather patterns. Starting with mountains, these dramatically affect weather by forcing moist air upwards. As the air rises over mountains, the air cools, and it then releases moisture as precipitation on the windward side, which is just the side that faces the wind. The other side of the mountain, which we call the leeward side, is sheltered from the wind and experiences something called a rain shadow effect, which basically means it gets much less precipitation because the air has already lost its moisture. This is why the western slopes of the Sierra Nevada mountains in California receive heavy snowfall, while areas like Nevada on the eastern side remain much drier. Moving on to valleys, these create their own patterns too, especially on clear, calm nights, when the ground cools down rapidly and chills the air right above it. When this happens, it can create temperature inversions, which just means that the normal temperature pattern gets flipped upside down. Normally, as you go higher up, like climbing a mountain, it gets colder. But in valleys, it's inverted, because instead of cold air being on top and warm air on the bottom, which is normal, the cold air gets trapped at the bottom while warmer air sits on the top of it. This can trap moisture near the ground, creating fog. As an example, Central Valley in California often experiences this effect during winter months. Finally, let's go over how ocean temperatures influence weather. Ocean currents act like conveyor belts, moving warm water towards the poles, here, and cool water towards the equator, which is this line here. Because warm water evaporates much more readily than cool water, when warm currents flow past coastlines, this increases evaporation and often creates more rainfall. Cold currents have the opposite effect though. reducing evaporation and creating drier coastal conditions. The Gulf Stream is a good example of a warm ocean current. It carries heat across vast distances, and is the reason why states like Florida tend to have much more humid conditions and hurricane activity, because the warm Gulf Stream waters provide energy and moisture, increasing the risk of storms. All of these factors, temperature, air pressure, winds, landforms, and ocean temperatures, work together to create the complex weather patterns we experience, which is why weather can vary so dramatically even between nearby locations.
If you haven't heard yet, you can find all of our videos on our website, cognito.org. You'll also find questions, flashcards, exam-style questions, and past papers. And we track all of your progress so that you always know what to study next. So sign up for free by clicking here, or browse our playlist here on YouTube.